Hello everybody, this is Basim with Join the Graph, and you're watching the third video in the JanusGraph installation series, where I show you how to install and configure JanusGraph and its storage backends on a Linux Ubuntu server. In this video, I'm going to show you how to install Apache Cassandra and how to configure JanusGraph to use it as its storage backend. First thing, we need to determine the version of Cassandra that's compatible with the version of JanusGraph that we are using. And to do that, I'll go to the GitHub website and I will search for JanusGraph. And I'll go to the release version of JanusGraph that I'm using. And you'll see under the tested compatibility section, it says it's compatible with Apache Cassandra, these versions. We will probably want to use the latest compatible version, which is 3.11.0 here. So I'll go to the Apache Cassandra website to download this version. It's cassandra.apache.org, and I'll click this download Cassandra button right here. I couldn't find the link to download 3.11.0 anywhere here, so I'll go to the archive and I will scroll down to 3.11.0. Here it is. And we need to download this first file right here. So I will copy the link location and I'll go back to my terminal. I will download it to the /opt directory. I'll use the wget command to download it. And here is the file that we downloaded. It's a .tar.gc file, so we will need to extract it using the tar command. So I'll say tar-x for extract and f for the file name. And here is the file name. And we just extracted the content from the archive and it was expanded into this directory you see right here. So always for my server software, I like to create a dedicated user for running the server software, like Cassandra in this case. So I will create a Linux user just for running Cassandra, and I'll do this using the add user command. The username will be Cassandra. I'll enter the password. So the user was just created, and let's make this user the owner of the Cassandra directory, Cassandra root folder. So I'll use the chown command -R to make it recursive because we wanted to own the Cassandra root folder and all its contents. And then the username is Cassandra, and the group name is Cassandra. And then the folder name. Let's go into this folder right now and do a long listing. You will see that Cassandra is now the owner of the root folder and all its contents. That's great, and let's examine the folder structure here. You see it's very similar to the JanusGraph folder structure. They have a bin folder under the root folder, and this is where you will find all the executable files. And they have a conf folder. This is where you will find all the configuration files. And right now we want to run the Cassandra server. So let's go to the bin folder and see which file. And before we do that, let's not forget to switch to the Cassandra user. Right now I'm logged in as the Cassandra user, and I'll be running the server as the Cassandra user. We're in the bin folder right now, so let's list the contents of this folder. You will see that we have this Cassandra file. This is a shell script that is used to start Cassandra. So I will run this shell script right now, and I will pass the parameter -f. So -f is a flag. It makes Cassandra run in the foreground. And this is helpful because it will allow us to see all the output messages from the Cassandra server. And we will also be able to shut down the server by pressing Ctrl+C on our keyboard. So this is very convenient. So I'll use this -f flag here. Okay, so the server was just started and it's now listening. It's running on the local host and it's listening to this port number 9042. Okay, that's perfect. So we have the Cassandra server running. And let's now configure JanusGraph to use Apache Cassandra as its storage backend. So I will open another terminal window and I will go to the JanusGraph root folder, the /opt/JanusGraph, and then I will go to the conf folder under the root folder and I list its contents. And if you remember from the previous video, the convention for naming these properties files, it always starts with JanusGraph dash, and then the name of the storage backend, Berkeley JE here, and then the name on the mixed index backend, Solar here. So for this video, we want to use Cassandra as the storage backend, and we want to use Lucene as the mixed index backend. So you will see that some of the files, they have Cassandra, the name Cassandra as the name of the storage backend, and others have the CQL as the name of the storage backend. So which one should we use? CQL is the Cassandra query language, by the way. It's short for Cassandra query language. We want to use the CQL version, like these files right here, not the Cassandra version. And this is because the files, the properties files that have Cassandra in their name, those will use Cassandra's thrift protocol, which is an outdated deprecated protocol. So normally you don't want to use it. And you want to use the CQL, which is Cassandra's newer communication protocol. So we will use one of these CQL files. And like I said, we want to use Cassandra as the storage backend, and we want to use Lucene as the mixed index backend. So we're looking for -CQL -Lucene. And unfortunately, this didn't come with JanusGraph. I don't have a -CQL -Lucene file. So let's create one. Let's create it by copying this file. I'll use the cp command, and we're copying this file. And the new file name will be JanusGraph-CQL-Lucene. And we just created it right here. This is the file we just created. So let's open it for editing in Vim. And it's a copy of another file, another CQL file. So it sets the storage.backend to CQL. This will make it use Cassandra, the storage backend, and use CQL as the communication protocol between JanusGraph and Cassandra. And we have the host name, it's the loopback address, because both the JanusGraph server and the Cassandra server are running on the same machine. And we have the Cassandra namespace will be JanusGraph. This is the Cassandra key space where JanusGraph will store the tables. And if this key space doesn't already exist, JanusGraph will create it. And we have a bunch of other configuration. And we need to add the configuration for making JanusGraph use Lucene as its mixed index backend. I don't remember how to write this configuration, so I'll copy it from another file. Let's open another terminal window and go to /opt/JanusGraph/conf and list its contents. And let's copy it from any other properties file that's using Lucene. For example, JanusGraph-berkeley-je-lucene.properties. Let's copy that and open it in Vim. And I'm trying to copy, yeah, here it is. That's index.search.backend equals Lucene, and index.search.directory equals the root directory /db/search index. So these are the two lines we need for configuring JanusGraph to use Lucene. I'll copy everything with the comments and everything. So I'll copy that and I'll paste it here. And then I will write to disk and quit. Okay, so now this file has all what we need to instruct JanusGraph to use CQL and Lucene. So if you remember correctly, the JanusGraph server does not use these properties files directly. It uses a YAML file that points to one of these properties files. So we will need to edit the YAML file and make it point to our new JanusGraph-SQL-Lucene properties file that we just created. And the YAML configuration file is under this folder right here, under the Gremlin server folder. So I'll go to this folder and I will list its contents. So this is the file we want to edit right here, gremlin-server.yaml. This is the YAML configuration file that the JanusGraph server uses by default if you don't specify any other configuration file. So I will open this configuration file for editing using Vim. And this is the line right here that we need to edit. Right now it's pointing to another properties file, which is janusgraph-berkeley-je-lucene.properties. This will make JanusGraph use berkeley-je as the storage backend and Lucene as the mixed index backend. This is not what we want, so I will edit that. And instead of berkeley-je, we will use the CQL storage backend. And I will write that and quit. Perfect. So now we're done with the configuration and we're ready to run the server. Let me clear the screen first. And like I said, I never like running server software as root, so I will switch to the Janus user, which we created in a previous video. And then I need to go to the bin folder, so I will go 2 levels up, and then I will go to the bin folder and list its contents. And this is the shell script that we use to start the Gremlin server. So I will run the script. Okay, and we just started the Gremlin server or the JanusGraph server successfully, and it's now listening to this port, 8182. We have a lot of terminals here, so let's label them to make it easier to understand what they have. This one, this is the Cassandra server. And this one is the JanusGraph server. This one, let me first quit this file. I'll use this one to run the JanusGraph client or the Gremlin console. So I'll call it JanusGraph client. And let's clear the screen. And I want to run the Gremlin console here to try accessing the JanusGraph server and testing it. First, I'll switch to the Janus user. And I'll go level up, and then I'll go into the bin folder and list its contents. And this gremlin.sh, this is the shell script that we use to start the Gremlin console. So I will run it. And we just started the Gremlin console. So now I will connect it to this JanusGraph server that's running on the same machine. And I'll use the remote connect command. And server. And then the configuration file, which is conf/remote.yaml. And I just connected it to the server. But that doesn't automatically send all the following commands to the server. You still need to precede all the commands with colon and greater than to actually send them to the server instead of executing them on the local Gremlin console. And if we don't want to remember to use colon and greater than in front of every command, then we can say remote console. This will send all the following commands to the server without having to precede them with colon and greater than. Okay, perfect. So now we're ready to start sending some commands to the server. First thing, I want to check the string representation of the graph object. to make sure that JanusGraph is using the configuration that we're expecting it to use. So the string representation of the graph object says standard JanusGraph. CQL, so it's using CQL as the storage backend. Perfect, this is what we wanted. And this is the server address, the Cassandra server address, which is the loopback address. Perfect, so it's using the configuration that we are expecting it to use. And now let's try creating a vertex. See if JanusGraph is able to communicate with Cassandra directly. Because when you create a vertex, JanusGraph will try to create this vertex or store this vertex in a Cassandra table. So I'll use g.addv to add a vertex, and the vertex label will be person. And let's give it a property. The property name will be name, and the property value will be p1. So I will execute that. And you see it was executed successfully and created a vertex, and here is the vertex ID. Perfect. This means that JanusGraph is able to connect with and communicate with Cassandra. Now I want to do something. I want to look a little bit into the Cassandra database to see how exactly is JanusGraph storing this graph information. So let's open another tab and put it right here. And this one will be the Cassandra client. So I'll change directory to /opt/Apache Cassandra, and I will go to the bin folder, and let's switch to the Cassandra user and list the folder contents. Okay, so the client for Cassandra is called CQLSH for SQL shell. So this is the file that you execute to start the shell script that you execute to start CQLSH. I'll try to execute it right now. And I got an error. It says no appropriate Python interpreter found. This is because CQLSH is a Python tool. So we need to have Python installed on the server to be able to run it. So I'll open yet another terminal to install Python. And we just installed Python on the server, so we should be able to run CQLSH right now. I'll try again. And it was started successfully this time. And I'm ready to enter commands. Okay, so first command I want to enter in CQLSH, I want to get a list of the key spaces. So I will say describe key spaces. And here are the key spaces we have on this Cassandra server. One of them is JanusGraph. And this is the key space that was created by JanusGraph, and all the JanusGraph tables will go under this key space. So let's use this key space. And now let's list the tables under the JanusGraph key space. So let's say describe tables. And here is the list of tables. All these tables were created by JanusGraph. The most important one is the edge store table. This is where all the graph information is saved. This is where the vertices and the edges and all the properties are saved. So this is the most interesting table, the edge store table. Let's try to see the data inside this table. So I say select star from edge store. And this is the data in the table. You see it's not really human readable, but at least now we know where it is. And this is just for the one vertex that we created. So it stored it in 20 rows. So it took 20 rows to store this one vertex that we created from the Gremlin console. So let's try adding another vertex and see how it affects this Cassandra table. So I'll add another vertex, another person with the property name equal to P2 this time instead of P1. I'll execute this, and the vertex was created successfully, and here's its ID. So let's see how this affected the Cassandra table. I'll execute the select command one more time. And this time we have 23 rows in the table. So clearly the table is growing whenever we add more data to our graph. So this vertex, it took 3 more rows. It was 20 rows before adding this vertex, and now it is 23 rows. So let's try adding an edge this time. Let's try adding a nose edge between person P1 and person P2. So I'll say g.add e, and the edge label will be nose, and it will be from g.v, the first vertex, and it will go to the second vertex, and to get it I'll say g.v and pass the vertex ID. So this will create a nose edge that goes from the first vertex, from P1, to the second vertex, to P2. Let's execute this, and it was created successfully. And here is the edge ID. It connects this vertex using the nose relationship to this other vertex. Let's see how this affected the Cassandra table. I'll execute the same select from edge store command one more time. It was 23 rows before, and now it is 36 rows. Okay, so this concludes this video. We saw how to install Cassandra and how to configure JanusGraph to use it. In the next video, I'm going to install a different storage backend. I'm going to install HBase, and we're going to configure JanusGraph to use it as its storage backend. So thank you so much for watching. Please stay tuned and see you next time.